So on this one, we will be writing a quick inequality statement, and that's it. So for the first one, we read, the cruising speed of the bullet train will be in excess of 150 miles per hour. That means that the speed is going to be more than 150, like that. For the second one, the distance to the nearest exit door is no more than 200 feet. So that distance must be 200 feet or less. It won't be more than 200. So less than or equal to 200. And that is how it is done. Just like that. Not a lot to do, but it is important to be able to do this simple problem so that when you deal with more challenging inequality problems, you're able to handle them. On this one, we draw a number line. And the only number we need to include is -5. The statement says we are interested in numbers that are bigger than -5. So I will shade to the right where numbers get larger. Numbers like -4, -3, and so on. I don't fill in the circle here because there is no or equal sign to suggest that we are including -5 in our shading. Just numbers that are bigger than it. Let's try another one. On this one, we are interested in numbers that are less than or equal to 7. So this time we shade to the left where numbers get smaller. But we do include this or equal to feature by shading in the circle on 7, suggesting that 7 is part of the solution set, not just every number smaller than it. Now we do the opposite of what we were just doing. Instead of being given the inequality statement and building the graph, this time we are given the graph and we will build the inequality statement from it. The numbers that are shaded in on this number line are all numbers that are greater than 5 or equal to 5. And that would be how we would do it. For this one, the numbers that are shaded in are all the numbers that are smaller than -5. So numbers less than -5. And because the -5 is not shaded in right there, we will not be including the or equal sign to include the -5 in the solution set. On this one, we are back to translating from English to math. So we have x is greater than or equal to -2, and at the same time less than or equal to 4. And that's it. Let's do another. 0 is less than w, and at the same time, w is less than or equal to 9. That's it. Now we isolate u. So u is on the right side of the inequality, and to make it so it is alone, I must move the -6 away from it. Therefore, I will add 6 to both sides of the inequality. which yields 19 is greater than u. That's all I have to do, but what does that answer mean? What would I shade in if I were going to do this on the number line? Certainly, it would be an open circle on the 19 since there's no or equal sign. But which way would I shade? Well, the statement says 19 is bigger than all the numbers we're interested in. So all the numbers we are interested in are smaller than 19. Another way to think about it would be to take this statement here and stick a pancake flipper under it, pancake spatula, and flip the entire thing over. And essentially, it would look like this. Notice the arrow is pointing at the U there. It's still pointing at the U. So everything is oriented properly. And here, it's a little easier to see that we're talking about numbers smaller than 19. On this one, the variable is being multiplied by something. The way we handle that is the same way we handle it if it were an equation. We divide by -6. Now, there's a couple of things we need to be mindful of in this particular problem. First, and most importantly, is when you multiply or divide an inequality statement by a negative number, the inequality symbol switches direction. Only when you multiply or divide by a negative. The other thing we need to be mindful of is dividing a fraction by another number, which is a little messy. So we could rewrite that as 10/7 divided by -6. Or 10/7 multiplied by the reciprocal of -6, which would be -1/6. With it being multiplication, I can cancel a factor of 2 on the top and the bottom. And now I get 5 times -1 is -5. And 7 times 3 is 21. So the answer would be all numbers less than -5/21. Once again, we are solving for x. So I need to move the 6 and the 5 away from the x. So if I subtract 6 from both sides, I get -10 is greater than -5x. Yes, that was a negative number, but I wasn't multiplying or dividing by -6. Therefore, the inequality symbol did not change direction. However, if I divide by -5, now the inequality symbol will change direction. And so our solution is all numbers greater than 2. This can be rewritten like that so that the arrow is still pointing at the 2. The significant difference between this one and the last is that we have these parentheses. So let's multiply away those parentheses, and then it will be just like the last problem. When I multiply the 4 through the parentheses, I get 8u plus 32 on the left side of the inequality statement. Now I can subtract 3u from both sides to get the u's together. And then subtract 32 from both sides. And when I divide by +5, the inequality sign does not change direction because I'm dividing by a positive, not a negative. And that would be the solution, done just like that. So on these, make sure that you get rid of the parentheses first. On this one, we have the problem presented to us in two parts. And so we need to solve both parts. So I do that just like we've done on previous problems. Now we're supposed to graph the solution, but I'm not quite sure how I'm supposed to do that, because after all, the first solution set says we are interested in numbers that are less than or equal to -5. And the other solution set says we're interested only in numbers greater than or equal to -2/3. So how do I combine them to make a single solution set? I recognize that they are connected using the word or. There's always two choices, and or. Or means take everything in the one set and everything in the other and keep it all. Keep all of it to make your solution set. So our solution set would be everything from 5 on down and everything from -2/3 on up. And that would be it. This time we have the word and connecting the two inequality statements. We'll start off the same way by solving both statements. But this time they are connected with an and. So as I graph the two solution sets, I get this. And the word and means that we don't take everything it's shaded in, like we did with or. Instead, we're only going to keep what they have in common, what satisfies this and this at the same time. So where the two of them overlap. It turns out they're going to overlap everywhere between -1 and 3, including -1, but not including 3. Notice 3 is not shaded in on both of them. Therefore, we do not include it. But -1 is shaded in on both of them. So it is included. Therefore, this is our final solution. Sometimes the compound inequality is disguised. This is actually an and statement. So to solve it, we do what we normally do. Whatever you do to one side, you do to all three. And so this statement says that our solution is going to be everything from -1 to 4, including those endpoints. And that's how that kind of problem is done. For this one, we need to build an inequality statement and then solve it. Company A charges $107, and that's it. Company B charges $55 plus another 80 cents for each mile. If M is the number of miles, what mileage will Company A charge less than Company B? So when is Company A less than Company B? Company A charges $107. And Company B charges $55 plus 80 cents for each mile. We now have an inequality statement that we can solve. And so Company A will cost less than Company B when the number of miles is more than 65. I said more because if I flip this thing around, it looks like that. When miles is more than 65. And that's how we do it.